Hi everybody, I'm Professor Rad, and today we're going to talk about how you can use what's called the IQR method to identify outliers in a data set. Now, in the last video, we talked about five number summaries, and you are going to need to know that material in order for this to make sense. So if you haven't seen that video, I want to make sure you go back and watch that one first. In a previous video, we also talked about outliers. And outliers are values in a data set that are strange or far away from the rest of the values in your data set. So for example, I have a data set here, 1, 2, 3, 4, 6, 8, 10, and 15. So a question you might ask is that 15 an outlier? Is it far enough away from the other numbers in the data set to be considered strange, or is it close enough? So what do you think? I think this question would be a lot easier if it was a 45, right? 45, definitely an outlier. It's like 35 above the next highest. So that makes that kind of a clear call to make. And maybe even 30 would be a clear call, right? Because it's still pretty far away from the rest of the numbers. But as we get closer to that 15, we might be wondering, well, where is the cutoff to decide whether or not something is an outlier? So, okay, maybe you might say 15 is not an outlier. It's pretty close to 10, pretty close to the other numbers. So we're going to say it's not. So what if it had been 17 or 20 or 25? How do you decide where that line is? Or maybe you think 15 could be an outlier. So what would not be? Would 12 be? How about 14? How about 13 and a half? So how do you decide where that cutoff is? So we're going to use this method called the IQR method to help us identify where that cutoff is for whether or not a value is an outlier. So in order to use the IQR method, let's define what that means and talk about why this might work. So IQR stands for the interquartile range. So the interquartile range, or the IQR, is the difference between the two middle-ish quartiles in your 5-number summary. It's the difference between Q3 and Q1. Okay, so that's our formula. Now, I want to point out that often in math, when you see a bunch of letters next to each other, it means some multiplication. That's not the case with IQR. The IQR is standing in for like a single number. Similarly, this Q3 doesn't mean like Q times 3 or anything. It just means third quartile. So our variables in statistics, we've seen some Greek variables already, and now we're also seeing some like combination variables, if you will. Then we're going to use that interquartile range to identify where those boundaries are that are considered the lower boundaries and the upper boundaries. And these are our formulas. For the lower boundary, we're going to take the first quartile and subtract 1.5 of the IQR. And for the upper boundary, we're going to take the third quartile and add 1.5 of the IQR. Okay, so let's see what these formulas are saying. So I'm going to bring some pink paper back over here. And let's sort of visualize what's going on. So we have our minimum in our data set, and we have the maximum. Actually, that's not how I want to visualize that. I'm sorry, let me restart here. So let's start out with the median. The median's in the middle of the data set. And then your Q1 is the first quartile, and your Q3 is the third quartile. So with these quartiles here, remember that this is 50% of the data and this is 50% of the data. And typically what happens in a data set is most of the numbers, now this is not always the case, and we'll talk about this later when we look at graphs, but you can kind of expect most of your data to kind of be bunched in the middle. And as you get closer and closer to the ends, it sort of thins out a little bit. So the IQR method says okay, this is kind of where 50% of the data is clustered. Okay, kind of a thing of this length. Now, as things kind of get stretched out towards the ends, we do expect some like sort of petering out on either end. So you expect some stragglers, but if it straggles out too far, then that will be an outlier. So to indicate that, I'm going to take this little box and stretch it a little bit. So this is that 1.5 times the IQR that's in our formula. And this box here is the IQR. So the IQR is the difference between the two quartiles, tells us that distance. And 1.5 takes that distance and stretches it. And basically what we're looking at for our outliers is we're saying this distance, if I look beyond Q3, that distance, okay, that's expected. So anything beyond this finger here, so anything that's out this way, is going to be an outlier. Or anything that's below Q1, so basically anything past the edge of this paper, would be considered a low outlier based on these distances that I've drawn. So that's kind of where those formulas come from. Since we're looking below Q1, that's why in our formula we have Q1 minus, because we're looking below Q1, and we're looking above Q3 to the right. So that's why here we have a plus, a Q3 plus. So let's go ahead and apply these formulas to finding the IQR and then these outlier boundaries. So I have a 5-number summary for a large data set. So here's our values, and we want to find the IQR. So the IQR is Q3 minus Q1. So Q3 is 58, Q1 is 47, and when I subtract, I get 11 years. Now let's find the lower boundary for outliers. So the lower boundary is Q1 minus 1.5 times the IQR. So Q1 is 47. And we just found the IQR to be 11. Now you can throw this whole thing into your calculator in one go if you wish, but I'm going to follow my order of operations. So order of operations says I need to multiply first. So 1.5 times 11 is 16.5. And I'm going to subtract that from this 47. And when I do that, I get 30.5 years. Excuse me. For the upper boundary, I'm going to do Q3 plus 1.5 times the IQR. Q3 was 58. And so I'm going to add 1.5 times that 11. Again, I'm going to follow my order of operations. So when I multiply 1.5 times 11, I still get 16.5. And I'm going to add that to 58. And when I add those together, I get 74.5 years. Okay, so what this means is that the middle 50% of data has a range of 11 years. So these ages in the middle are pretty close together. They're only 11 years apart. What we're saying is based off of that, we would expect the data to fall between 30.5 and 74.5. Anyone who is older than 74.5 would be considered an outlier. That would be strange. And anyone younger than 30.5 would be pretty young compared to the rest of the data. So that would be considered an outlier as well. Now, they didn't present the whole data set to us here. They just said it's a data set that's large. But they did give us the 5 lowest values and the 5 largest values in the data set. And they're doing this so that we can identify which values are outliers. So for the lowest values, anything smaller than 30.5. Okay? So anything smaller than the lower boundary is an outlier. So if I look at these numbers here, 25 is an outlier because that's smaller than 30.5. And then the 33 and 34, these are not outliers because they are bigger than the boundary. So they work. So one of the outliers in this data set is 25 years old. Then we do the same thing with the largest values, although this time these are things that are to the right of the boundary. So anything larger than 74.5 is an outlier. So we've got 72, 73, 75, 78, and 86. So these are all outliers because they are larger than that boundary. So 75 years old, 78 years old, and 86 years old. So this large data set had quite a few outliers. So it looks like it had 4 outliers here. So let's go ahead and do another example of identifying outliers. All right, so in this example, it looks like we've started it, and that's because we worked through half of this example in the last video. So we had this data set of temperatures for over a month, and we found our 5-number summary over here on the side. So now what I'd like you to do is to find the IQR, the outlier boundaries, and then to list any of the outliers in the space provided. So I'd ask you to pause the video here, work through it, and then you can unpause the video and I'll have my work here and you can check to see how you did. Alrighty, so let's see how you did. So I got an IQR of 10 degrees Fahrenheit. My lower boundary was 38 degrees Fahrenheit and my upper boundary was 78 degrees Fahrenheit. Don't forget to label. And based off of that, I found 2 outliers, 36 degrees Fahrenheit and an 86 degrees Fahrenheit. So I got my IQR because I did 63 minus 53. That gave me the 10. For my lower boundary, I took Q1 of 53 minus 1.5 times the IQR of 10. And that gave me that 38. And then for the upper boundary, I took Q3 of 63 and I added 1.5 times 10, and that got me to the 78. So the way that I got this 36 and this 86 is I looked at my data set up here, and anything that was smaller than 38 was an outlier. So 36 was an outlier, and then the next smallest number was 42, so that one was safe. It was bigger than the lower boundary. And then anything that's bigger than 78 is going to be an outlier as well because it's above the upper bound. So coming now from the right, 86 was higher than 78, but 77 was not. So 77 was safe. So that's how I got these 2 outliers. Now, one thing I want to point out is these 2 examples that we worked on in this video were specifically to help us identify outliers. But the case may be that you have no outliers in your data set. So if this 86 wasn't here and if that 36 wasn't there, I would still do all the same work, and for the outliers, I would just write none. It may also be that you have some of these upper outliers, so some values on the top end, but not so much on the low end. Or vice versa, you could have some outliers on the low end, but not have any on the upper end. So just because we happened to find multiple outliers in these examples doesn't mean that that's always going to be the case, right? So hopefully you don't have, too many outliers. Hopefully you don't have any, because again, they lie outside the expected range of your data. So that's unusual. That's not something that you would typically expect to happen. So in our next video, we are going to use these 5-number summaries and this analysis to get us some outliers. We're going to use that to help us create a type of graph called a box and whisker plot. So I am looking forward to seeing you then. In the meantime, have an excellent day. Bye for now, everyone.